No, it's still in your hair.
What is it? What is it? That's a wasp.
Is it gone?
Hey, it's gone.
The nest is still there, but the pattern is gone.
He was just tangled in your hair.
So you're awake. You're awake now. All right, so hope everyone had a good weekend. So next Monday, right, a week from today, we have our first exam. And what I would expect is that I will send a review out through Canvas email. I will send that out tomorrow, okay? All right, so tomorrow, check your email sometime midday. I'll send out a review, and then on Wednesday, I'll come in here and hopefully answer questions that you would have on that review, all right? I think I told you one of the first days that my reviews, if you can do the review, you'll be fine for the test, right? So you'll want to get this and take some time with it tomorrow evening, and then come in and anything you don't understand, I can try and clarify. As far as the material that'll be on this exam, it'll be everything we do everything we've done up to today and up through Wednesday. So there's going to be stuff on the exam Monday that we don't cover until next class. So just be aware of that, all right? For the exam on Monday, I'm not going to be here to give the exam. So I'm going to be out of town on Monday. So I have a proctor coming in, and they're going to just have instructions to come and have y'all sit down, we're going to change the seating in the room so that everyone's kind of facing the same way. You won't be in little groups at tables. And then you'll be taking the test, all right? So I will ask you and advise you and remind you that on the test, I expect you to be doing your work, right, and not your neighbor's work. And so the proctor will have instructions that if he sees anything like that, he'll remove you from the room. So yeah, I've had it happen before, so just want to kind of make sure you're aware of that, all right? Any questions on that? Okay. All right, so let's get going here. We are going to continue. We did not finish last time. We were talking about several things, but we had finished up or ended when we were talking about polynomial operations with polynomials, and I had gotten through, we had at least discussed the first three of these. So I wanted to pick up here on number 4 and see if we can handle it. So number 4, let me make this a little bit bigger. Number 4, you're asked to find 4x minus 3, that quantity squared. So one thing I'll point out right now, and hopefully you notice, is that this is not an equation, is it? Remember, we spent some time last class solving linear equations, right? And one of the keys is that we had to have an equal sign inside there for it to be an equation, which meant that we would get a solution like x equals 2 or something like that. Here, we're just asked to perform the operation, which means we need to do whatever the operation is, we need to actually carry out the operation. So like in this problem, we're supposed to subtract these, and we combine like terms. Here, we're supposed to take this and actually square it. And then, so our answer is going to be still an expression with variables in it. It's not going to be like x equals 2, right? So when you see 4x minus 3 squared, I guess we just have to make sure we understand that when you see anything squared, it just means multiplying it times itself, right? We want to multiply it times itself. So when we square this, we're just going to get, what, 16x squared minus 9? Is that right? we just square this? So we square the 4, it becomes 16, square the x, it becomes x squared. And then we just do minus, then we just square that and it becomes 9. Is this right? No, this is wrong. This is what most students that are unfamiliar or uncomfortable with this do. Does it seem, I mean, wouldn't it be nice if this was it, right? But this is not what it is. Okay, so this is wrong. What it is you have to take 4x minus 3 and multiply it times itself, right? That's exactly what it says we do if we ever square something. So how do you multiply those two together? Distribute, right? Now, some of you have learned this thing called FOIL. You all ever heard FOIL before? Yes, FOIL. So the correct mathematical term is distribute or expand. Okay, so, but the FOIL thing, a lot of students like it, so I'll write it here. What does FOIL stand for? First, outer, inner, last. It's just a way of remembering how to do this sort of multiplication. But the key is with FOIL, you can only do this if you have two terms and two terms. So if you have two things, then you use FOIL. If you have like 2 things and 3 things, you can't use FOIL. But let's just carry on with this. So the first thing to do is to multiply the first 2 terms together. So first term times first term, right, like that. And what would we get there? 16x squared. So that's that, right? Okay, so we have that so far. That's good. But then you do the first term, the outer terms, right? So the outer means this one times this one, right? So what is that? Minus 12x. And then you do the inner terms. So you multiply negative 3 times 4x, which gives you another negative 12x. And then you do the last terms. Negative 3 times negative 3. Negative times negative is positive, so you get plus 9. And there's one more step. What is it? Combine the like terms. So these two are the same, like terms. So we put those together, we get 16x squared minus 24x's, and then plus 9. So this is the answer. We have expanded this. We have performed the indicated operation, which is what the instructions say. Does that look familiar to you all? Seen that? Okay. All right. I want to kind of do this a slightly different way. I'm not going to try and confuse you here, but when we did first, right, we really just did this one right here, and we just multiplied it here, right? That's what we did. And then when we did outer, we stuck with this same one, and we multiplied it here, yes? So it's really what we did is we took the first term and kind of passed it through both, right? Then after that, we moved on to the next term, and then we passed it through both. That's essentially what FOIL was, right? I like to look at it that way because of the next problem. Number 5. So number 5, you cannot use FOIL. Why can't you use FOIL? Yeah, one of them has 2 terms, right? This one has 2 terms, but this one has 3. So whenever you have 2 terms times 3 terms, you can't use the FOIL. I'm sure we could come up with some cute word to do it, but let's just follow the process. Let's do the same thing we did when we were doing FOIL. Start with the first term, right? And what we're going to do is we're going to pass it through to all 3 terms. After we do that, we will move on to the negative 3 and pass it through all 3. Okay, so we're going to have a total of 6 multiplications to do here. Agreed? So what is the x times the x squared?
X cubed.
So we get x cubed, bless you. And then we do x times 3x, which is plus 3x squared. Then x squared times positive 9 plus 9x. Okay, so we've done the x passed through everything, right? Now we move on to negative 3. Negative 3 times x squared gives us negative 3x squared. What's our next term? Negative 9x or minus 9x. And last term? Minus 27. So negative 3 times positive 9. And then we go and collect any like terms that we have together again. So we have some like terms, right? Actually, what happens here? A lot of them cancel, right? Like this 3x squared cancels with the minus 3x squared. And then the 9x cancels with the negative 9x. So at the end of it all you're left with, just turns out in this problem, is the x cubed minus 27. And we're done. Okay? So the point of this is that if you have 2 terms times 2 terms, you can use your FOIL. But if you have something else, 2 times 3, or even if you had like 3 terms times 3 terms, you would just have to start with the first one, pass it through, go to the next one, pass it through. Make sense? Okay. Any other questions on that? Well, you haven't asked a question, so any questions on that? Okay. So that last one I think you could handle, right? That's just, you could just do the FOIL on that. I won't work through it. Try and show you something. Have you ever kind of wondered, maybe not, but have you ever wondered why something like x plus 2 squared, why it's not equal to x squared plus 4? Like we tell you you're supposed to multiply it times itself and do this thing FOIL, right? But why is it not that, right? Like, why does it have to be this thing, x plus 2 times x plus 2, and then FOIL out and get x squared plus 4x plus 4? Like why that? Why the FOIL, right? So I'm going to try and show you like a visual explanation as to why this is the way it is, all right? So why is it this and not this? So I'm going to do this. Does everyone know that if somebody gives you a rectangle, that the area of that rectangle is your width times your, we'll call this length. Length times width. So the area of that is length times width. Are we all on board with that? Okay? All right, so with that, let me see if I can explain why this is true. So what I'm going to do is I'm going to get out a ruler here. All right? And I'm going to measure some distance. Ready? Here it comes. So I'm going to start here. I'm going to measure across to here. And that distance from there to there, I'm going to call that x. Okay? And then I'm going to add to that some distance here. And let's say I measure that to be 2. So from here to here is 2, and from here to here is x. With me? Now I'm going to do the same thing. I'm going to take this measurement right here, x, and I'm going to put it vertically like this. Let me see, hold on. It was like this, so it's about there. So from here to here, that's x. So that distance from there to there is also x. And then here to here, right, that's 2. I put that there. That distance is 2. All right, good? All right, so now, what is the total length of this side? How long is that side? It's x plus 2, right? So this is x plus 2. All right, what is the total length of that side? X plus 2 again. Feel good? Make sense? All right, so now I'm going to start drawing some other things in here. So what if I went here and I went straight up and straight over like that? Can you tell me the area of that? It would be this distance times that distance, right? So the area of this is x squared, all right? What if I went from here to here and I went up and across here? What's the area of this rectangle? So 2 times, how tall is it? X, so this is 2x, right? Yes? Now what about this rectangle, if I draw this rectangle from here, here? So how wide is it? X, how tall is it? 2, so this is also 2 times x, right? Last one, this little piece right here. What's the area of that? 2 times 2, so this is 4, right? So the area of this entire thing, right? What is the area of the entire thing? All of them together. It's this one plus this, which is 4x, right? Plus this piece, which is 4, right? So the area of the whole thing should be this. But what is the area of the whole thing? It's this side, right, times this side, which is really x plus 2 times x plus 2, right? So we're saying that this is equal to x plus 2 times x plus 2 again. So x plus 2 squared. Does that make sense? Yes. Visually? If it doesn't, don't worry about it. I'm just, for those of you who want to see why, that's why. All right? If you do this, then what you're doing is you're only picking up this piece and this piece, but you're totally missing those two, right? So that's why they're not the same. Okay, moving along. Sometimes it's worth it to kind of know why instead of just following orders, right? Unless you're in the military, right? Then you just follow orders. All right, so now let's do some applications. So these are some geometry problems. This is really kind of just testing some of the, to see if you understand some of the language we use. So look at this first problem, number 7. Write a polynomial that represents the perimeter of this figure. So let's start calling on some people. How's Stephanie Cruz doing today? You're okay? All right. Good. So do you recognize perimeter? So in your own words, what is the perimeter of an object? Add up all the sides. Okay, so it's like the distance around. Like if you had to walk around this thing, you would measure the distance. So you're just going to want to add up all the sides, right? Is everyone okay with that? So we want to act like we're walking from here, and then maybe up to here, and then back down, right? And then back over. So if we want to measure all that, we just need to add up all those sides. Add them, right? Not multiply, add. So we're just going to take 3x squared minus 4x plus 9, that's one side, plus the next side, 2x squared plus 4x minus 10, and then add to that the last side, which is 5x plus 3. And this would be equal to the perimeter, right? And now that problem is very much like the problems we did last class. Can we just drop the parentheses here? Can we? Can we just get rid of them? Yes, because there's a 1 out here. And then this is being added, right? So can we just drop these? Yes. And then this one's being added, so we just drop that. So we're just going to basically collect like terms together, aren't we? And so let's see, what are our like terms? Let me see if, is it Caroline? Caroline? Can you give me what this perimeter is with the like terms added?
All three together?
Yep. So start with like the x squareds. How many x squareds do you have? 5x squared. Go ahead.
The 4s would cancel each other out.
Okay, these are gone.
And you have 5x.
So you still have that 5x.
And then it would be positive 9 plus negative 10, which is negative 1 plus 3 is 2.
That's better than I could have said it, I think. Everyone agree? Okay, so that's it. Notice that your answer, your perimeter, is still an expression, right? Because we don't know what x is. So they want the answer. They say write a polynomial that represents the perimeter. They're not telling you to find the perimeter like, you shouldn't expect to get an answer of like 40 feet or something. Our answer is still a polynomial expression. And we're done, okay? Let's move on to the next one. Can I erase? Anyone still need it? All right, so let's read through this. Find a polynomial that represents the area of the shaded figure below. The dimensions of the white square are x by x. So when we're talking about area, right, the previous problem was area. Lisa Q? Yep. What? It's okay. So Lisa, area is different than perimeter. Can you explain? Tell me anything you know about area.
It's within the box, but not the smaller box. So looks like it's X.
So let me stop you at area. You said it's within the box. So when we talk about areas, we're not talking about distances around anymore, right? We're talking about like if you had to paint this, like how much paint you would need is an area. It's two-dimensional instead of one-dimensional. And we want the area of this piece, right? So can you tell me what the area of this big piece would be. Let's just imagine that wasn't there, it was just a box. So how do we find the area of a rectangle?
So would we do 2x times, 2x
Yep.
negative 5
Uh-huh.
times 2x negative 5. And you'd
Okay, let me write that down. So yes, so you're going to find the area of the big box, which is 2x minus 5, times itself, right? I'm going to put squared. And then I think you're going somewhere else now with this.
So if you were to do that, you would cancel out the 2x with the 2, if it was next to each other, it's 4x.
Well, this is like what we just did a second ago. We have to square this, right? So we have to do like a FOIL to this.
Yes.
That would give us the area of the whole thing, right? That's not what we want though, right? We actually want to take this piece out. So we want to subtract from that the area of the smaller box, right? This little smaller box. Now, do we know the area of this smaller box, Lisa? So they give us the dimensions. See, they say the dimensions of the white square are x by x. So x by x. So we don't know what x is, right? So what is the area of that piece? X squared, right? So this piece right here has an area of 2x minus 5 squared. That's this whole thing. And we're taking away from it the area of the smaller box, which is x squared. Does that all make sense to everyone? Big square without taking anything out. Take out that little middle piece. So this is the computation that we need to do right here. Right there. And Andrea? Where's Andrea? Okay. Andrea, I was going to give you a moment to FOIL that first piece out for us. I'll kind of take my time writing as you FOIL. Not to put you on the spot or anything.
So you would multiply the 2x times 2x.
Okay.
4x squared.
Good.
And you would multiply 2x by negative 5, which is negative 10x.
Good.
And then negative 5 times 2x is negative 10x again. And then negative 5 times negative 5 is 12.
Okay, so that is the expansion of this. And then we also have the minus x squared out here, right? That's that piece in the middle we're taking out. So let's include that in our line. And the last thing to do here would be collect like terms. And we're done. So I think y'all can handle this. 3x squared minus 20x plus 25. So the 4x squared, take away, this is like a 1x squared, so that gives you your 3x squared. Then combine your negative 10x's together. That's it. So if somebody were to tell us now what x is, we could figure out what the area is. But someone would have to tell us what x is. All right, is this reasonable? So this is a perimeter problem. I'm not going to do this one. We're just going to talk about it. So write the polynomial that represents the perimeter of the parallelogram. Does it really matter that it's a parallelogram? It really doesn't matter because they give us the lengths of all the sides, right? So all we're going to do here is just add up all these sides again. And that's going to be pretty straightforward. So I'm not going to go through that. This next one, though, says write the polynomial that represents the total number of square feet for this floor plan. So this looks like a little small apartment. No bathroom, apparently. You just have, I guess, this is where you come in. This is the door. You come in. It's like your living area, and I guess like a bedroom, and then like a game room. Closet. Yeah, it has windows, so who cares? Let's find what the area, square footage of this place is. So let's see who can help with this. How about Macy? Where's Macy? Macy, okay. You understand the problem? They want some polynomial representing the total square footage, so area. So how are you going to handle that?
You're going to multiply the length and the width, so it'll be 12 plus x.
You're going to multiply the length and width together. So you're saying this distance from here to here is what? 12 plus x. Does it matter, Macy, if we flip it? It's the same. I'm going to leave it like that because that's the way you said it. And then from here to here, what is that?
X plus 30.
X plus 30. And all you did there was just put x plus 6 plus 24, so that gives you x plus 30. Okay, so we got our two sides. Now what did you say we need to do with those? Multiply them together. Okay, so the area should be the 12 plus x times the x plus 30. And then you do your little FOIL. Did you already do it? No? Okay, so what is our first term here? 12x. So, yeah, 360. So I always like to just do like 3 times 12, 36, add a 0. So plus 360 plus x squared is the middle one there. And then plus 30x. So I'm going to write it this way. X squared plus 42x plus 360. So I wrote it in what's called descending order, which means the highest power of x, and then I move down. It would not be incorrect, okay? If you wrote it like this is not incorrect, right? This is still correct. It's just not in descending order, and there's no rule that says it has to be in descending order. So this would be acceptable, this is acceptable. You could even switch these around if you want. But this is it. This is your polynomial that represents the square footage of this apartment. All right, I think we're done. We need to talk a little bit about factoring now. So we're kind of like all over the place here, aren't we? I mean, like started off, we were adding and subtracting fractions, multiplying, dividing fractions, then we did some solving linear equations, and then we've done some polynomial expression stuff, and now we're going to move to factoring. So there will come a point where it seems like we're not jumping around so much, but this is still technically kind of review. I mean, this is all stuff a lot of you have seen. So let's talk about factoring. So factoring is your second favorite F word. So what is factoring? What is factoring? Okay. So if you take like the number 14, right? 14 actually comes from two numbers that are multiplied together, right? What two numbers? 7 and 2. I'm put them in order smallest to largest. So 14 is the same as 7 times 2. So this is actually what you call factoring a number. You take a number and you break it down to smaller parts. Now each of these parts happen to be prime numbers. Do you know what prime numbers are? So prime numbers are numbers that are only divisible by themselves and 1. Themselves and 1. So what are the prime numbers, just out of curiosity?
1, 3, 5.
So 1,
1, 3, 5.
2. What about 2? Is 2 divisible by?
1.
Is 2 prime? You only have to be divisible by yourself and 1, right? So 2, the only number you can divide into 2 evenly without getting some remainder is itself, 2 divided by 2, right? Or 1. How about 3? How about 4? 4 doesn't work because what can you divide into 4? You can divide 2 into 4. So 4 doesn't work. How about 5? 5. How about 6? How about any even number from here on out? No even numbers will work because any even number I come up with will always be divisible by 2. So the next one is 7. What's the one after that? 9. But 9 you can divide by 3, right? 11 would be the next one. 12's out. 13 would be the next one. How about 15? No, because you can divide it by 5 or 3, right? 17 would be the next one. And this list goes on and on. Actually, the list goes on forever. There's an infinite number of primes that never stops, okay? Now, there's a question here. Is 1 prime? I would say it depends on who you ask, right? But mathematicians don't consider 1 to be prime. But we're not going to get into that. We'll just, if you want it to be prime, fine, it's prime. All right, we won't argue about it. So those are our prime numbers. Start out with any number. Okay, this number right here is called a composite number. And the reason it's called composite is because it is composed of primes. So whenever you take a composite number, you can factor it into its prime called prime factorization. Okay, so it's two prime numbers, right? Those are on that list that multiply to be that number. Okay? Let's do another one. There's a reason I'm doing this. I'm going to tell you a pretty interesting story here. Well, it's going to be interesting to me. I'm not sure if it's going to be interesting to you. Okay, take the number 28. So can you give me a prime factorization of this? So just start out with anything you can think of that multiplies to be 28.
4 and 7.
4 and 7? Okay. Now are both of those prime? No, 4's not, right? So 4 can be broken down to be what? 2 times 2, and then what we do is we just bring the 7 down also. So 28 is 2 times 2 times 7. And all of these are now prime. So this is called the prime factorization of that number. Y'all with me? Mm-hmm. All right.
So what if you used 14 times 2?
What if we use 14 times 2?
It'll still be snagged.
So, well, let's see. 14 times 2, right? 14 is not prime. 14 can break down to be, how do you want me to do it?
2 times 7.
2 times 7, and then we still have this 2, right? So look at this. 2 times 7 times 2, but that's the same as 2 times 2 times 7. So all prime factorizations are unique. So if we all start with the same number, we should all get to the same prime factorization, no matter what. All right? So this is how we factor numbers. Our goal is to be able to factor algebraic expressions. So the whole idea of factoring is starting with something and breaking it into multiplication, right? Starting, breaking it into multiplication. All right, so let's see about this one right here. Let me think. Where's the problem we started with? Where is it? I forgot the problem, so I need to go back up here. 4 minus 3 squared. So what if I asked you to factor 16x squared minus 24x plus 9? So this is kind of a trick question, because the only way you really know this is if you've learned this technique already, or if you remember we just did this problem. We started class with this problem. What was the problem I asked you to do that we started with? Was it the one 4x minus 3 squared? Wasn't that what we did? Yes? And then when we did this, didn't we get this? We did, right? So this expression up here, look at that as being like the number 14, okay? Can you break this down into two things that are being multiplied, just the way we broke 14 down to be 2 times 7? Well, yes, we can break it down to be 4x minus 3 times 4x minus 3. Do you all agree? Yes?
Yes.
So this, from here to here, is called factoring. And when we factor is one of the most difficult things that students struggle with, all right? Well, all I want you to take from this is that the idea of factoring is turning an expression into things that are being multiplied. The first technique we ever learn when we factor is something called GCF. All right, so we'll get to how you could go from here to here. We know how to go from here up, right? Going from here back, that's a little more involved. We'll get to that. But the first thing you always do when you learn to factor is this thing called GCF. So factoring, first step, always, all right? So this will always be our first step. It's called GCF, which stands for greatest common factor. Oh, whoa, I don't know what happened there. Common factor. So let's do an example. I'll just make one up. All right, so how about this? What if I ask you to factor 3x squared minus 15x? All right, so somehow you've got to turn that from that into two things being multiplied, all right? Okay? So this first technique of greatest common factor means what you're going to do is you're going to look at in this case, 2 terms, right? We have 2 terms. You're going to try and figure out what they have in common. Okay, so what do they have in common? So let's look at the numbers. 3 and 15, right? Can you think of a number that goes into both 3 and 15? 3, right? 3 goes into 3 one time. 3 goes into 15 5 times. So they both have in common a factor of 3. So what we do is we write that. I'm going to write equals. I'm going to put that right here like this, 3. That's what they, and you know what, on the side here, I'm going to write it down. What is the GCF? What is the greatest thing they have in common? Well, they both have a 3 in common, right? Now look at the x's. This one has how many factors of x? 2 factors of x. This has how many factors of x? 1 factor of x. So what do they have in common? Just 1 factor of x. So your greatest common factor here is the 3 that we talked about before in the x. Okay, and there's nothing left, right? We've talked about the numbers, we've talked about the letters. So what we do now is we write the greatest common factor out here, out in front, and then what we do is we put a set of parentheses. This is going to be our multiplication, and what we're going to do is try and come up with what goes in here. And the idea is that if we multiply this through to 2 different things, we should get back this. Okay, so what would I have to multiply 3x by to get 3x squared? I'm just missing an x, right? I already have the 3. I have 1 factor of x. I need 2 of them, so I just put an x here. Everyone agree now? If I distribute that through, I get 3x squared?
Yes.
Okay, and then what do I multiply 3 by to get negative 15?
5.
Negative 5, right? So I need minus 5. And what about turning my x into x? Well, it's already x, right? So if I just do 3x times negative 5, I should get back this. Okay, that's GCF at its most basic level. You just look at your expression, try and find what they have in common, put it on the outside, parentheses, enough space in here for how many terms you have here. So if I have 2 terms, I need space for 2 here. If I have 3 terms, I need space in that parentheses for 3 terms. All right, so let's do a couple of these that are on the assignment here. Yeah. Remind me when I finish this GCF section, if you remind me, I will tell you a pretty cool story. If you want to hear it, if you don't want to waste time on it, we don't have to. But it's math related, so maybe you really don't want to hear it. Okay, so let's go with number 11. We'll start out pretty basic here. Milena? How's it going, Milena? I thought that was a Houston Texans shirt, but no. My dad had that exact shirt on yesterday.
Really?
Yep, exactly. Yeah. Well, I don't know if it was exact same brand, but it said the same thing. Okay, first one right here. Okay, so we're asked to factor. Okay, first step to factoring everything that we ever see is GCF. Okay, so I'm going to write this down. Can you tell me what the greatest common factor is, and maybe kind of how you're, like what you're thinking? 6. That's it, right? So that's the only thing these 2 things have in common, right? Like you look at each one of them, look at the numbers, they both have a 6, right? Now as far as letters are concerned, one of them has a y squared, the other one has no y's, so they don't have anything in common in terms of y. So that's your GCF, that's it. So now you would write what? You'd say equals, and now what would you write here? 6, and then parentheses, okay? You want to do a parentheses? How much space should I allow myself in here? Enough for how many terms? 2, because this is starting with 2, right? So enough space for 2. And now you kind of play this little game. So y squared plus 1, very good. So you have to have the 1 here, don't you? Because look, you have to go through this to get back 2 terms. Sometimes students will be like, oh, well, I don't need anything because I already have a 6, so they don't put anything here. But there's a problem with that, right? Because if you multiply this together, all you get is 6y squared. So you have to put a plus 1 so that when you distribute, you get the 2 terms. Good. All right. Frank? How's it going, Frank? Good. All right, Frank, you get number 12. Can you see it?
Yeah.
Sure. You make it a little bigger. You all right? All right, so Frank, when you look at this one, GCF, what are you thinking here? What do they have in common? Y squared, and that's it, right? So when you go through and try and find out what they have in common, I always like to start with numbers. Like, what number do they both have in common? Well, they don't, right? This one has a 1, this one has a 3. They don't have anything in common, right? So then I move to the x's. This one has 1 factor of x, this one doesn't have x's, so they don't have anything in common. But they both have a y squared. And because of that, since you have 2 factors in each one, y squared can be our GCF. Now, Frank, we're going to put the y squared out in front of a parentheses. Enough space for how many terms, Frank? 2, okay. And then what are those terms in there going to be, Frank? X. Okay, so that'll give us this first one, right? So multiplying this times this will give us this. And then you said what? -3. There we go. So we're trying to turn y squared into -3y squared. The only thing we were missing was a -3, so you put it there. All right, good. I think someone's ready for number 14. It looks worse than it is. How many of you would agree with this statement, that math is easy when you know what you're supposed to be doing? And math sucks when you have no idea what you're supposed to do, right? It's like impossibly hard. And there's not a lot of things that are like that when it comes to academics. Like, you can still write a paper even though you may struggle with certain things, but in math it's like, if you don't know what you're doing, then you're stuck, right? So when you see something like this, even though it may look intimidating, if you understand what you're supposed to do, then just execute the procedure, all right? So we're looking for GCF here, and let's see who our lucky one is here. Christine Gonzalez? Christine? So Christine knew not to come today. Christian, right? Christian? 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 Christian also knew not to come today. Itzel. This making sense so far? Okay. So when you look at this one right here, GCF. Start with the number. Any numbers that go into 16, 28, and 48. So this might take a little time, but 4, okay. So what we want to ask ourselves is, does 4 go into all these numbers? 4 go into this, yes? 4 go into that? 4 go into that. Now you want to ask yourself, is that the biggest number? And I think it is, right? Because the reason I know that is because how many times does 4 go into 28? 7 times, and 7 is prime. So I know that there's no other bigger number that could go in. But just by inspection, I think we could all get 4, okay? You want to keep going? Okay, good, thank you. How about x's? Just one x. Now, does this one have an x? No, so do they all have a common factor of x? They do not, right? So no x's, right? How about y's? Y squared. We have 2 factors, 5 factors. You can only pull out what they have in common. So they all have at least 2 factors of y, right? So y squared. Are we done, Itzel? 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 Yes, Itzel. Okay, so 4y goes out here. So I'm going to say that equals 4y squared, and then parentheses, enough space for how many terms in here? 3, because we started with 1, 2, 3, right? So kind of make it pretty big. And now, what do you have to multiply this by to get back this? So what are you missing?
X squared.
Okay, we need the x squared. That'll give us that. What about the 16? 4, right? We have to multiply the 4 times 4. So we need the 4, and we need an x squared. Do we need any y's? No. So we're done there? Okay, we're going to move on. Kiana? Where's Kiana? How's it going, Kiana? Good. You get the next term, Kiana. So what do you have to multiply 4y squared by to get to negative 28xy squared? It's going to have to be negative, right, everyone? Because you're starting with a positive 4. So you're going to need a negative, right? Seven. Okay. So that'll take care of our number, right? That'll give us negative 28. Now what about, we need xy squared. So what do we need to include there? We need an xy squared. All we have is a y squared. So what are we missing? Just one x, right? And that's it. So that goes here. And we're done with that one. And let's see. Is it Aliana? Wait, no, hold on. I think. No? Ali, I'm making it too hard. Here, you can help. Thank you.
Aliana?
Aliana.
Did I say it right? No?
Elena. Why? Because that's, yeah, it is. It's Elena. See it again? The eye is kind of messing with you, right? Elena. Okay, it is what it is. I'm going to do my best. I'll try. It's going to take a couple times. It might never happen, but I'll try. Okay, Elena. Last term.
Plus 12y cubed.
Okay, plus 12. That'll give us our 4 times 12 gives us our 48. And then you're saying we need y cubed, right? And that's because you have 2 factors here. You're going to need 3 factors in order to create 5 factors total. And that's it. We're done. That is factor GCF. What do y'all think? It's okay? All right, last one. Give you a second to look at it. Remember, GCF is only the first step for factoring. Later on, when we're doing problems, we'll be doing this step, and then we'll be following it up with more steps. But for now, this is all we're talking about today. So GCF, and we are at Tiani? Yes? Good. Tiani. Yep. What do you see, Tiani?
Let's start off with the numbers.
Numbers?
Yeah.
Okay. What do you got?
Thinking is it 5?
5? What do y'all think? 5? Yeah, I don't think you can get anything bigger into any of those, right? Yeah, okay. How about x's?
I want to say x squared.
X squared, okay. 3 factors of x, 2 factors of x, 4 factors of x. You can only take out what they have in common, x squared. Okay, y's?
Y cubed.
Y cubed. Okay, so that's what's going to go outside the parentheses. 5x squared, y cubed, parentheses, enough space for 3 terms. Do you want to keep going? Sure? Okay, so you want to basically take this, multiply it by something to get back that. So what do you got?
I'm going to do 5.
5x. Almost.
And then
Is this going to give you back that? So you get 5 times 5 is 25. X squared times x gives you x cubed. Y cubed times y. So you still need a y there, right? That'll create your 4 factors of y. Now you can move on to the next one. So how many times I got go in there? 13 times. So minus 13. Any x's? No x's. How many y's? 2 factors, right? So y squared. And the last one, 5 goes into 80 16 times. So minus again, right? And any x's? Squared, right? X squared. Any y's? No, don't need any y's. And we're done. All right. Do y'all want a little story?
Yes.
Sure. But, all right. So, take you back to this. I mean, this is relevant, all right? So, you know when you, I'm trying to think of how far back I want to go with this. Have you ever heard of cryptography? Any idea what that is? Well, it has something to do with computers, I guess, in some way. Cryptography or code breaking, you know. So think about this. All right, this is a very, very basic idea. For a long time, human beings have wanted to send messages back and forth to one another, right? So think back, way back before telephones, before, you know, if you wanted to send a message, y'all have heard of, was it Paul Revere, the guy on the horseback?
Yes.
Is that the one during the war? The what? When the British are coming, right? Okay, so he's out there, he's yelling at people like, get your shit ready, like they're coming, right? Like there was no text, there was no Twitter update, right? Like that was the way you sent the message, right? So the problem with sending messages, sometimes you don't want other people to intercept that message, right? So if I want to send a message to you, I could, you know, write it down on a piece of paper and send it to you, but if someone intercepted that, they would then have the message, right? So for as long as humans have been around, we've been trying to send messages back and forth to one another, right? And sometimes the people who are sending the message have come up with very clever ways of doing it, and the people trying to intercept the message have been not able to intercept it. And even if they do, they don't know what to do. So let me give you a very example of a code. And this is very basic. Okay, so let's say what I do is I do A, B, C, D. I list out the alphabet, right? All the letters. And then for each letter, I give it a number. So 1, 2, 3, 4, 5. So if I sent the message 414, then what would that message be? Dad, right? That's very basic, yes? Pardon?
When you do that, it reminds me of 2319 from Monsters, Inc.
20. I'm not familiar.
Oh, well, it's the scene where he comes out of the kid's room and he has like a white sock on his back.
Uh-huh.
And they yell out 2319, which is WS, because it's a white sock. Yeah.
23rd letter, 19. Really, I did not know that. That is interesting. Huh. That's very obscure. Okay, that's cool though. I like that. So this would be the code DAD, right? So like let's say I wrote down 414 and sent it and someone intercepted that. They're like 414. They might be able to figure it out. Like if they say, okay, I understand they're assigning a number to a letter, right? They would probably be able to break it. I mean, they should, right? So then maybe you become more complicated, all right? Maybe you do something like, you know, you do A, B, C, D, right? And maybe you scramble a different way. Maybe you start out here and this is 3, 4, 5, 6, all right? So, but the person on the other end receiving the message would have to know how you scrambled it. Does that make sense? Like if I sent 414 to you and you knew I was using this scrambling, then you would say Dad, right? But if I sent 414 and I use this, it's going to say something else. So the problem with that is even the person on the other end has to know how you scrambled it, right? So how do you get that message to them of how to scramble it? You're in a problem. You have a problem, right? Because you still have to send that message. So you run into this huge problem. So throughout history, there's been this battle back and forth. The people trying to break the code and the people trying to create the code. And World War II was a huge example of that. If you've ever heard of the Enigma machine the Germans made, it was supposed to be unbreakable. And what's the movie? There's a movie about it. Anyway, it's not important, but the British and Americans were able to break the Enigma machine. We were able to figure out how to do it, and we learned a lot about what their plans were because of that. So it's just been this historical battle going back and forth, back and forth, back and forth, until this thing came out called Rsa Encryption, all right? So these are the people trying to scramble the code, right? Not the code breakers, and then you have the code makers. The code makers came up with this thing called Rsa Encryption. And here's how it works, okay? This is the way it works. I'm going to try and break it down as simple as I can without getting too technical. Let's go back to that number 28. Remember I said that could be broken down to two, well, you know what, let's not do 28. Let's do something a little bit, let's do 14. I think I wrote 14 first. That can be broken down to 2 times 7, right? Okay. So imagine this. Imagine this. Here we go. I'm over here. Here's you, okay? Here's me. And here's all the people listening, trying to listen to us, all right? Trying to break our code, all right? So they want to know what I'm trying to say to you, all right? So here I am, and what I'm going to do is I'm going to yell out to you, 14, okay? 14. They can hear it, right? They hear 14 also. So what you do is you come over here and you get my number 14, and somehow you use that number 14 to scramble your code. You know how I was saying like A is 1, B is 2? Just believe that there's a way that you can use that number 14 to create a scramble, all right? Now what you do is, now that you have it scrambled, you send me the message back to me, all right? I get that message and I unscramble it. For me to unscramble it though, I must know that 14 is 2 times 7. So let's just run through that again. I yell 14, you use 14 to scramble, you send me the message, and the only way to unscramble it is to know that 14 was 2 times 7, all right? So do these people know, do they know the number 14? Yes, right? Okay. Do they know what the original message these people is trying to send? Like if they're trying to say help, do they know that these people are saying help? No, because they're going to scramble this, right? When they send it back to me, are these people going to see that scrambled thing? So let's say the scrambled thing is QWE, L, right? So they hear 14, they scramble their message, they yell it back, and now they hear it, right? QWEL. Can they unscramble it?